In this video, let us see the third property of an analytic function. The property is any two harmonic conjugates of a given harmonic function u in a region differ by a constant. That is, any two harmonic conjugate means here as usual f of z is equal to u plus iv means v is the harmonic conjugate of u. Okay, so here two harmonic conjugate we have to consider. So two harmonic conjugates means let us consider V and V dash. So like this U plus IV, we can consider another term that is U plus IV dash. Okay, so both being analytic function. So since both being analytic function, it will satisfy Cauchy-Riemann equation. So that here it becomes dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. Similarly here for u plus I v dash, dou u by dou x is equal to dou v dash by dou y. Similarly dou u by dou y is equal to minus dou v dash by dou x. So since here if you see the first equation dou u by dou x, here dou u by dou x, from these two, this and this, we can have dou v by dou y is equal to dou v dash by dou y. Similarly from these two equation, we have minus dou v by dou x is equal to minus dou v dash by dou x. So obviously here we can cancel minus and minus. Okay, both are same. Since both are same, we can have dou by dou y, that is dou v by dou y minus dou v dash by dou y is equal to 0. Similarly, dou v by dou x minus dou v by v dash by dou x is equal to 0. Or otherwise this we can write dou by dou y is common. We can write v minus v dash is equal to 0. Similarly here dou x of v minus v dash is equal to 0. So whenever the derivative of a certain function is 0, then we can conclude that that function will be a constant function. So which means that this is equal to, that is v minus v dash is a constant. Now let us see the fourth property. That is, if f of z is equal to u plus iv is an analytic function, then the family of curves u is equal to a and v is equal to b cut each other orthogonally, where here a and b are constants. The same property can also be stated like this. The real and imaginary part of an analytic function form an orthogonal system. Because the real part is treated as u and imaginary part is treated as v, so u and v form an orthogonal system. So how to prove this result? So here already it is given that u of x comma y, that is u is a function of x and y, which is equal to a. Another equation v of x comma y is equal to b. So both are represents the system of equation, and then here this u is a function of x and y, which means that x and y are independent variable, which can be written as dx is equal to 0. That is, by differentiating u, that is du is equal to 0, because right side is constant, it becomes 0. Similarly here dv is equal to 0. Since du is equal to 0 and u being function of x and y, we can write dou u by dou x into dx plus dou u by dou y into dy. That is, using total differentiation, we can express du as dou u by dou x into dx plus dou u by dou y into dy. Similarly, dv can also be expressed as dou v by dou x into dx plus dou v by dou y into dy is equal to 0. So from these two equations, we can write dy by dx. Let us consider from this first equation, dy by dx can be written as minus dou u by dou x by dou u by dou y. Okay, so this term, if you take it to the right side, it becomes minus of this. So dy by dx can be written like this. Similarly, here from the second equation, again here dy by dx can be written as minus of dou v by dou x divided by dou v by dou y. Right? So here this generally dy by dx is represented as slope. So we can write this as m1 and this is m2. Since we need to prove both the curves cut each other orthogonally, the condition is m1 into m2, that is product of their slope should be minus 1. So we have to prove m1 into m2 is equal to minus 1. So that here if we prove m1 into m2 is equal to minus 1, we can conclude the result. So here what happens, since both the functions are analytic function, that is f of z is an analytic function and u and v are the real and imaginary part of an analytic function, here Cauchy-Riemann equation satisfied. So since Cauchy-Riemann equation satisfied, here this dou u by dou x can be written as dou v by dou y divided by dou u by dou y can be written as minus dou v by dou x by Cauchy-Riemann equation. That is this, here we can write it as by Cauchy-Riemann equation. So this m1 can be written like this and here minus and minus get cancelled. Okay, so let it be equation 1 and this m2 let it be equation 2. So now from equation 1 and 2, what happened here is if you multiply 1 and 2, which gives you left side will be m1 into m2, which is equal to dou v by dou y by dou v by dou x into here minus dou v by dou x by dou v by dou y. So here both are reciprocal term if we multiply, which gives you minus 1. So m1 into m2 is equal to minus 1, which implies both u and v cut each other orthogonally. So that's the proof of the property.